Hello, everybody. My name is Kevin Kamek, and I want to introduce you to my networking project on how to create your very own game server. In this series, we are going to cover up a few topics to understand the very basics of TCP and game networking development. Um, on the top left of the screenshot, you can see the server console application where you can see incoming connections. Also, you will be able to control the server by a few commands, in example, kicking a connecting player from the server. And also in the screenshot, you can see three other console applications, which represent the different clients which are connected to the server. And you will be able to chat with each other also through the server. The topics we are going to cover up are the basics of the TCP sockets, to understand how a network stream is working, how you are able to send informations like strings, integers, and whatsoever over the network. How the network works as its own. And we're also setting up a multiple client game server console application, which you saw in the screenshot right here, which allows us to let multiple people connect to the server at the same time. As I already said, we are allowing incoming connections to the server. Not only we are able to connect to the server or ping the server, we will be also able to connect with him and also to communicate with the server. We are going to specify every incoming connection with its own ID, which basically means the first player, since we are using arrays, the first player which is connected to the server is the player 0 and has the connection ID 0. The second player will be player 1 in the array and also will get the connection ID 1, which has which will help us pretty much because you want to send specific data to a specific player. Therefore, you need a connection ID, the socket itself from the player, from the personal player. So you only send the information from the server to a specific client and not to everyone. Also, we are going to set up a basic game client console application, which you also saw in the screenshot, which basically means we are able to communicate with each other through the server. We can write chat messages and everyone can see it. And we are going to connect with the server, which is a little different because when you are connecting to a server, you are already sent data information from your computer to the server. And we are going to cover that up, how you can connect to a server in an efficient way. There are multiple ways to connect to a server, like flooding the server with requests and stuff like that. But we are going in depth with the connection between the server and the client. Also, we are going to create our very own network message system, which means or which allows you to send information easily from the server or from the client to the server or the client, which basically means normally you are sending information in a string, convert the string into a byte array. But in our case, we are going to create a list and convert this list into a byte array, which allows us to create easily network messages with a few settings and which will increase your development stage. Also, we are covering up how to receive the information correctly, which means once you are sending out the data from the server to the client want to receive the information correctly in the correct order. Also, we are going to cover up packet loss prevention, which is a pretty huge topic, which basically means once you send out information, you send out a network package from the server to the client multiple times at the same time, it can happen that the client is not that fast and will drop one or two important messages. So, in example, you are sending out 5 packages, network messages. the client only receives the last two, in example. We are going to cover up how we prevent that and how we are going to receive every single network package in order. Also, we are going to set up the server console application on a Windows virtual root server, which allows us to allow connections on the server from all around the world. Yeah, that's basically the project information. And you may ask, what can I do with that? Well, basically, it is pretty simple. This is a base project. This is the base of every game server. You can basically create your own game logic in it, which allows you to create a powerful MMORPG. But by understanding the TCP connection itself, the IP protocol, how it works, is it either UDP or TCP, you have then the knowledge to create your very own game server and create your very own MMORPG or any online game you want. I hope you guys are as excited as I am. I wish you the best of luck. I wish you the greatest, and maybe we are going to see us in my video. Thank you for tuning in, and bye.
Hello everyone, and welcome to the first episode on how to create a game server and client with C# and TCP. In the first episode we are going to create the server itself with the IP protocol TCP and using Visual Studio 2017 and C#. I would say without further ado, we are going to start directly with the project. To start the project, we are going to open our Visual Studio 2017 and we are going to create a new project. So we are hitting on File, New Project, and we are going to use a console application because our server runs the best on a console application. We are naming this console application, in example, TCP server. That sounds like a great name. We are hitting OK, and we are waiting till our computer has created the project. There you go. All right. Before we start, you have to make sure that everything you run in a console application or within a console application will start on this method, on the main method, okay? But there's also something different from a Windows Forms application, because once you're running this project, a console application directly, you hit start or debug, and what happens is you will see your console application and it will close directly. That's the first mistake everyone is doing. Because how a console application is working, it starts the console and then the console is executing every code within this method, and after everything is executed, the server will close, or the application will close down. To prevent that, we are going to create a new thread which allows us to run the console over and over again without much resources. And to do that, we need a simple new directive. So on top of the project, you see the directives like using system and the rest of it. Probably you got other stuff, but we can delete everything besides using system, and we are going to add using system.reading. All right. As next, under our class program, we are going to create a new thread, which will run our console application on a new thread. So we are going to use private static thread, and we call this thread console. After that, we are going to create a new method, which will be our server loop. The server loop is basically something which keeps the console application alive and won't close directly after you have started it. So we are going to create a new static void, and we call this, instead of thread console, we call this console thread. You can call it console loop or whatever you like. All right. Within this console thread, we want to make sure on the later videos as well that when you type something into your console application, that you can execute methods out of it, okay, or events or whatever you like. But first of all, we want to create a string, which we call line, and also a string array, which we call parts. The reason why we're doing this is because we are reading out the current line the console application is. So when we are typing something in the console application, that the line is getting read out by the application itself. And the string array parts will be later on our, let's say, event handler. So when you type in example / kick, if you want to kick a player, then is this your command, and the part of it, the array, will be then the player name in example. Okay, but to keep this console application alive, we are going to make a while loop, and we say while the application is true, then nothing happens, okay? Which is then an infinite loop, which keeps the console application alive. And because we are having a thread, or have created a separate thread for that, this is not as resource taking as if you're going to make the while loop directly in your main method. Okay, that is bad coding. You don't want to do that because that will take up a lot of resources later on your server, which you then can invest, which you cannot invest into the game mechanics itself. All right, that's it. But now we want to make sure that the thread console will get started, okay? For that, we are going to create the thread console equals new thread. And we do need a parameter-sized thread start, which is then our console thread method. Then we are going to say new thread start, and we are going to input as a parameter our method console thread. There you go. All right, and then we can say thread console dot start, and now everything is working correctly. So now when we hit start, our console application should stay open, as you can see right here. And on our diagnostic session, you see the resources, the process memory over time. It just takes up 7 megabytes. And that's basically nothing. Great. Now we have created a new thread, and now we can focus on our server itself. So as I already said, we are going to create the server itself with a TCP listener with sockets. And yeah, that's what we are going to do right now. For that, we are going to create a new class. To do that, we right click on our project here on the Solution Explorer. We add a new class right down here. And we call this class, in example, server TCP. Great. Awesome. Again, you can delete everything on top of that besides system, because we need system always when we are coding, but we are adding something different. We are creating, or we are adding, using system.net, which allows us to get access to all the networking stuff within Unity. And also we are using system.net.sockets, which grants us access to the sockets itself to create a TCP listener, a TCP client in example. And yeah, perfect. Now we are directly going to create our server socket. So our server socket is a TCP listener, which is a wrapper about pure sockets. You also could go sockets, in example, socket, new socket. Let's say socket equals new socket. Then you can create a socket type, in example, which you can see a dgram is for UDP, which is also great for games, creating games. And or a stream. A stream is basically for TCP, because how TCP IP protocol as TCP works is it sends out information from the server to the client within a certain time. So it gets us a setup amount of data information, it gets it together and then sends it at one time to the client, which is actually a great thing, because UDP is creating DQAM, or is using DQAM, which sends one packet as a stream. And you cannot compare those two. One package on UDP has its own sending information, but the stream on TCP will gather all information together and then sends everything together to the client, which in my opinion is the better way. But there are people out there which who discuss about that, like I love TCP, but UDP is the perfect fit for games and anything like that. But if you're creating a game like a 2D game, or I don't know, an online strategy game, TCP is the perfect thing for it. You only use UDP for like shooter games or fast-paced games. But for example, MMORPG, you can use UDP and TCP, and actually World of Warcraft is using TCP as a protocol, which is actually huge. Okay, so enough talk. Let's go into coding. We are going actually to create a private TCP listener right here, and we call this server socket. And that's it. Now we have created our server socket parameter, a variable, sorry. And now we are going to set up this variable a little bit to make it fit and to start the server itself. For that, we are going to create a new method, which we are calling public void initialize network. Okay, in this method, we are going to set up the server socket, which allows us to start a server and allow connections on the server. So we are saying server socket equals new TCP listener. And now we are actually accessing our using system.net. We want to allow every connection, so we want to allow every IP address out there to connect to our server. Therefore, we are going to use IP address.any, which actually is a setup to allow which we want to open. In this case, for the tutorial purposes, we are using the port 555 and 5. Don't ask me why, it is just a random number. But yeah, as next, to start a server, actually, we have to call the start method. So we say server socket.start. And that's it. Now our server actually is able to start. Okay, and you will see how that works. But first of all, we are going back to our program class to call the thread the server TCP socket, server socket.start. To do that, we are actually going to create a new class, because I want to have the code very clean and very organized. So we are going to create a new class, and we call this class general. In this general class, we are actually is actually where all the magic happens. Okay, so in general, we will call everything which we want to call at the server startup. Therefore, we are going to create directly a new method which is called public void initialize server. Perfect. I always wanted to make sure that I see what is going on with the server when he starts up. So, and I also want to know how fast the server is working once he is creating all the stuff and while he is initializing everything. So to do that, we are going to create a new variable, a new function, which is called public int. And we call this get tick count. Okay. In this get tick count, we are returning our environment dot tick count. Tick count, there you go. With that, we are able to count the milliseconds, how long the server is taking to start up actually. Don't forget, you can delete everything on top of that besides using system. And now we actually can start working on initializing the server itself. So we are going to create a new variable which we call int start time is equal 0, and then int end time, which is equal also to 0. Then we say start time is equal to get tick count to make sure, okay, the server is starting, the server is initializing, and now we can count how long it takes till the server initializes everything. Then on the next line, we're hitting a comment. Well, I'm hitting a comment because I always comment my code, so I know what is going on. So I say I want here to initialize all the game data arrays, which we are going to make in other videos. So initializing all game data arrays. Okay. Here we are going to initialize all game data arrays, I guess in the second video already. But now on this video, I want to start the networking itself. So here we're going to start the networking. And now we are directly we are going to create a singleton. A singleton is basically you call another script, another class in this class to access it methods. So to do that, to call the server TCP initialize network, we need to create on our general class a public server TCP. We call this server is equal to new server TCP. This allows us to access everything which is public on our server TCP. Okay, so now we can say server dot initialize network. We can hit a comment over there, so we can say console dot write line. We can say initializing network dot to make sure, okay, now it is initializing the server at the network, and on top of that we can say console dot write line initializing server dot. So we know, okay, the server is initializing, then he's initializing the server, and yeah, perfect. Then we can say the end time is equal to get the count as well, and then we can say console dot write line. We can say initialization. This is a hard word, to be fair. Initialization complete. Server loaded in. We hitting a parameter right here. Server loaded in that amount of milliseconds, and now we can hit our object, which is basically our end time minus the start time. That's it. This value now is getting counted and will be passed in right here when the server is done. Okay. Now we actually initializing the network, initializing the server, but now we need to call this function, this method, initializing server, in our startup method right there. To do that, basically, we are going to create again a singleton, which is basically a private static general. Call this lowercase general equals to new general. Now we can access our general class, and we can say general dot initialize server. Awesome. Perfect. Now we are able to start the server. So when I hit start, what should happen? My Windows firewall should pop up and should ask me if you really want to make the server public, and then you hit yes, and then everyone is able to connect to your server. So let's hit start. What happens right here is, as you can see, my Windows firewall is asking me, okay, allow the networking stuff. You say, okay, I allow that. And now you can see in your console application, initializing server, initializing network, initialization complete, server has loaded in around 62 milliseconds. And that's how you basically set up a TCP socket, a TCP listener, and to allow or to start up the networking itself. So your network is open now and people are able to connect to your server. When you have opened up your project, like I did, we are actually going to add another project. So right click on your Solution Explorer, right click and add a new project. In this case, we are going to add another console application, and we call this, instead of TCP server, we're just saying TCP client. Well, we cannot actually use this name because we are going to create a variable which is called TCP client. So therefore, we are just saying client, or better name, we are going to say game client. Okay, let's create this project. Okay, so we can close everything else like on top of that. And now we have our client. As you remember from the first episode, we have created a server TCP, and therefore we are going to create a new class on our game client project. And we call this class actually, let's say, client TCP. Okay. In this client TCP class, we are going to create the client socket, the player socket, and we are setting up this socket and we are trying to connect to the server with the socket. So to do that, we can again delete everything on top of that, besides using system, of course. So we are saying using system.net.sockets. Okay. And now, instead of creating a TCP listener, we are going to create a TCP client. So we are going to use a public TCP client, and we call everything player socket. Okay. And basically that's it. That's enough what we need to actually trying to connect to the server. But for that, we need to make a few settings first. Okay, we are going to create a new method which is called public void connect to server. In this method, we are creating a new instance of our player socket, which is called player socket equals new TCP client. Okay, now here's the thing. We do need to set up our stream, our player socket, how we receive data and sending data out. In example, we are going to say we want to gather like around 4,000 bytes till we are making the first send call. And the same way, we want to receive 4,000 bytes till we receive another package. This, which is basically you can send a lot of data at the same time, which makes the networking really, really fast. Not as fast as UDP, but it makes it really, really fast to send out data and to receive data. And to make the setting, we can actually say player socket.receive buffer size is equal to 4096. Why we are using this number, you can also say 182. But I'm using 4096 because we are sending a lot of strings, a lot of integers, a lot of data, and that's why I want to increase the amount of data I want to send for each networking call. The same way we want to send it out. So player socket.send buffer size is equal to 4096 as well. Okay, and now we need to create our buffer byte array. which stores all the information which we are sending out or receiving. To do that, we are going to create a private byte array, and we call this byte array asynchronous buffer. So in this case, async buffer. And now we are assigning the size of our byte array, which is then asynchronous buffer is equal to new byte array. And the number, we want to increase the size of our array with both our receive buffer size and send buffer size. So we can do the same stuff at the same time. So we can send and receive at the same time, if you know what I mean. So in this case, if my math is correct, the size will be 8192. Let me recount. Yeah, that's the correct number. And then after that, we are actually able to connect or call the method to connect to the server directly. So our client is set up basically with the very basics. And now we can say player socket dot begin connect to our IP address. We can add a port. We can make a callback, which basically says, okay, you are connected to the server, and so on and so on. So to test that, we are going to say, since we are on localhost, we are going to say our IP address is 127.0.0.1. Our port, which we did set up on the first video, was 5555. So we are going to add 5555, hit the comma, and now we need a async callback, which basically means once the server receives the information, it sends information back that you are connected to the server. That's how TCP works. It is a three-way handshake. That basically means you send a request, you get a request back, and then you send the method. Okay. So we are going to say our async callback will be new async callback, and then we need to pass in our method. So basically our method name will be connect callback, and which we are going to create in a second. And our object state will be our player socket, because we want to know if our TCP client right here is connected or not. And that's how you connect to a server properly. But now we need to create our async callback method connect callback. So we are going to create a new method, which is called private void connect callback. And now we do need a parameter, which is to make asynchronous callbacks. We do need a parameter of async result. And we can call this parameter just result. And yeah, now we can say once we are successfly connected to the server, this method is getting called, our connect callback. So we can say console.writeLine successfully connected to the server. That's it. Later on, when you continue watching these videos, you will receive information like packages and stuff like that. But for now, for the tutorial purposes, we are going to just say, okay, there's the information, we are successfully connected to the server. Good. Now we actually need to run the connect to server method in our program.cs again, because we're having a console application. As you remember from the last video, we are going to create a general class which handles all methods. So adding a new class and calling it general is the right way to do it. And in this general, we are creating a new instance of our client TCP. So we are saying public client. We need to write it within the class. My bad. So public client TCP, we call this client, is equal to new client TCP. Now we are creating a method, the same like on the server, but in this case we are saying public void initialize client instead of server. Now we are hitting a comment which says connect to the server, and now we can call client dot connect to server. Now we just need to call our initialize client within our program.cs. For that, again, we are going to create a new thread like on the server on episode 1. So we are saying we are using system.threading. Okay, now we are creating a new thread. So we're creating a private static thread. We call this thread console, and we are passing in our general. So we say public static general, calling it general is equal to new general. Now we can say in our main method, we are creating the new thread of our thread console. So we say thread console is equal to new thread, which is a new thread start, and our console thread, which we are going to create in a second as well. Then we can again say thread console dot start. After that, once our thread has started, we can call the general dot initialize client, which lets us connect to the server. Now we are creating our console thread, so we are saying static void console thread. Awesome. The same stuff we are preparing. So we are saying string line, string array parts, and then we can say console.writeLine in example initializing console thread. There you go. And then again, to let us or to keep the console application alive and open, we are again hitting a while loop, while true, and passing nothing in there yet. Okay, that's basically it. We could test this right away, but now what happens? So let's start with the server. Okay, so we are starting with the server, start new instance. So our server is started. Now when we are starting our game client, debug.start new instance, we are saying, okay, initializing console thread successfully connected to the server. Okay, but there is no information that the client on the server is actually connected. Okay, so when we are closing down the server and closing down the client and just open the game client without opening the server, so start new instance, as you can see, it still says successfully connected to the server, which basically makes no sense, right? So for that, we basically need to make sure that we keep trying to connect to the server over and over again with our player socket begin connect. So what we need to make basically on our connect callback is we need to make a try catch block. So basically we are creating a try catch block, which lets us, when we are actually successfully connected to the server, which then ends the connection. So basically you are connected to the server, but it ends the process trying to connect to the server, else you're connecting over and over and over again. So to do that, we are going to say player socket.end connect, and then we are passing in our async result, and that's it. And now we are basically connected, or it says, okay, now we are connected to the server, and now we are ending trying to connect to the server because we are already connected to the server. And then we can say, we can basically make a check if there is actually an error happening. We can basically say if player socket dot connected equals false, then basically we can say return. So we are returning the whole code. But else, if we are connected, okay, so if we are connected, we can basically say, instead of return, we can say console.writeLine can't or cannot connect to the server, and else we can say console.writeLine successfully connected to the server. So now we can test it. So when we are debugging our game client, so right click, start new instance, what happens now? Initializing console thread, but now you see an error. Okay, you cannot connect. It is in German on my side, so excuse me. You are not able to connect to the server because the server is not online. Now you are getting the error. Okay, so that's basically perfect. So now we can say catch exception. We can basically say console.writeLine cannot connect to the server. So what happens now when we are starting the game client? Start new instance, boom, initializing console thread, cannot connect to the server. Awesome. That is working properly. Good. Okay. And what happens here in our if statement? So when we are connected to the server, but the server does not allow our connection, then this line will print out. So cannot connect to the server, must be changed into server does not allow our connection. But on our server project, we actually set up that we allow every incoming connection right here. So this error should never print out. If so, you're basically doing something wrong. Okay, so back to the topic. We have now a callback when we are trying to connect to the server. But now we should allow the connection on the server. So when we are starting the server right here, and going back, starting the game client, what happens is start new instance. We are successfully connected to the server. We are connected successfully to the server, but actually we are not, if that makes sense. We are able to ping the server, okay, but we are not into the server because our server has no function yet to allow our client to be a part of the server, to receive data or send data. That's a different. You are able to ping the server, you know, okay, the server is online, you are able to reach the server, but you are not actually connected to the server. If that makes sense for you. So to make that, we are going back into our server project right here, server TCP. And what we need to add is basically that we are accepting every incoming connection to be able to communicate with the server. So we are saying on our server project, on our server TCP, we are saying server socket dot begin accept TCP client. We're only allowing TCP connections, okay? And then again, we do need a async callback, which we can create right now before we moving further. So we are going to create a new method called private void on client connect. Again, we do need a parameter because it is asynchronous. So we do need a async result, which we are calling result. Okay. So this method is getting called when someone is trying to connect to the server, which we just did. We tried to connect to the server, but we are not actually able to get into the server. And with this method, we actually allowing the player to be a part of the server. As I already said, you are connecting to this, or you are pinging the server over and over and over again till the server says, stop it. You are connected to the server. You don't need to try to connect anymore. And that's what we are doing right now. So we are creating a temporary TCP client. We call this client. And this client is equal to server socket dot end accept TCP client and then our result. So what that means is basically our game client is connecting to the server. Okay. So the game client is pinging the server to try to find the server. Okay, the server is found and then he is trying to connect. So this method is called, so begin accept TCP client. And then this method is called, which basically means, okay, you are trying to connect. We are ending your connection request and allow your connection on the server, which then sends a request back to our game client, which then says, okay, boy, stop trying to connect. You are connected to the server. We are now able to communicate with each other. And that's what we're going to do. So our server socket begin accept TCP client. We do need our async callback, which is our on client connect right here. And now we need an object state. We don't have an object state like on the client. So we are just passing in the parameter of null and that's it. Nothing else to do. So to allow more connections on the server, you are able to call this line again. So what happens here when you're passing it in, or if you forget to begin accept the TCP client again? So what happens here? We are starting the server. The server says, okay, a TCP client is able to connect. So someone is connecting to your server. Then this line is getting called. It says, okay, you are connected to the server, but then a second player is trying to connect to the server, but he's not able to get into the server to communicate with him. Why is that? This is because we are ending the connection, but we are not calling the begin accept TCP client, so another one can connect to the server. So that's why we are saying begin accept TCP client again. So this is like an infinite loop to will be able to connect to communicate with your server. That's it. That's why you call this line again after you're ending another TCP connection request. Okay, that's it. So I think we could test it. So when we hit start on our TCP server, basically we could say console write line connection received from, we're passing in a parameter, object, excuse me. So we want to print out which IP address is connected to the server. Therefore, we can say, we can print out the IP address of the incoming connection. We can say client.client, uppercase client, .remote endpoint .toString. This is actually showing the actual IP address and the socket port. So you need to differentiate between the server port and the socket port. A socket port is a thing for itself. It gives the player a certain socket port, which then is getting used to send information again back and forth between server and the client. Okay. Actually, I have a great example. So we are commenting out this line to show you a little example that only one client actually can connect to the server. So we are starting the server. Okay, initializing server, initializing network, initializing complete, server loaded in 78 milliseconds. Okay, now we are going to build, yeah, I want to stop debugging. We are going to build the game client. Build, we right click and we are open the file explorer. Go into bin and debug. Now we have the game client. Now we can start the server again. Starting the server, okay. Go back into our folder and open up our game client. So what happens now? When I open up the game client, it should print out on the server that there is an incoming connection. So let's test that. And as you can see, connection received from our local host, because we are testing it on localhost, and our socket port. Connection received. Awesome. But what is now when we are going to open up another game client? So we are open up the game client, and as you can see, we are able to ping the server, but we are actually not allowed to connect to the server, because the server does not allow another person to connect. You only can connect one time to the server, and that is a problem. But what if when we are closing both clients, then you should say, okay, now no one is connected anymore. Is that right? That's wrong. When we open up another game client, as you can see, we are not able to connect to the server anymore. Why is that? Because we are only calling the begin accept TCP client one time at the very start when we are setting up the server. That's why you only can connect once to the server. Else you have to restart the server, then you can connect again once to the server, then you have to restart the server, and then the client can connect again once to the server, and that's totally messed up. And that's why we are calling server socket begin accept TCP client after someone is connected to the server. So what happens now is when we are starting the server, we are open up a game client. As you can see, again, connection received. And now actually we can open up a second game client. And as you can see, another incoming connection, because we are calling the exception multiple times. And as you can see, again, we have the same IP address. Both clients have the same IP address, but have different socket ports, which is necessary to send data to a specific person. And now we can add a third client, and we have a third incoming connection. And yeah, that's how you actually accept multiple incoming connections on the server with the client, and how you connect with the client to the server. And that is episode 2. I hope you liked it. I hope you learned a little bit, and hopefully you guys see us in the next episode. And yeah, take care. Good luck in your project, and see you guys very soon. Bye. Hello everyone, and welcome back on how to create your own game server and client. In today's episode we are talking about on how to make every client unique, and how to identify each client, and how to connect with multiple clients, and also how to allow a maximum amount of connections. I would say we are going to start right away without further ado, and we are directly going to start with our server. So within our server TCP class, we have created our on-client connect method, okay? So where we accepting and receiving and ending the incoming connection from a player. But now we want to store all the client information within a separate client class. This has some benefits, which also makes every client unique on its own. And so you can access every client by itself and make changes without even change other clients. It sounds very complicated, but it will make a lot of sense for you. So before we start creating everything in our on-client connect method, we have to create a new class, which is actually called just client. So we're adding a new class on our server, and we call this class pretty simple clients. Clients sounds pretty good, so we add that. Okay, so what do we need in our clients class? So basically we don't need anything besides using system and using system.net.sockets. Okay, so this class, which we are going to multiply later on, to allow multiple connections, to allow a certain amount of players on the server itself. So we want to store a little bit of information from the player in this class. It is not a player class as you just have in your mind, like where you store username, password, location, level, items. This is completely different. This is the class where the player is stored on the server. Okay, so we do need a few parameters, a few variables, which allows us to create a client on the server from the player. So for that, we are going to create a public integer, and we call this connection ID. So what is this connection ID? The connection ID basically is pretty simple explained. It is the, let's say, ID of the player on the server. So when no one is online on the server and you are the first person accessing the server or connecting to the server, you are the player 0. So why you are the player 0? So it is pretty simple. We are using arrays, and array starts always at index number 0. Okay, so therefore the first player is number 0, the index number 0, and the last person, when we say we are allowing 100 people playing on our server, the last index is actually the index 99. So you have exactly 100 people on your server starting by index 1, not 0. Always remember that. So we assign the player a connection ID, which allows us later on in the game logic to access the specific player. Okay, so we have the connection ID. As next, we want to make sure that we know the IP address of the player. Okay, so we say public string IP address. This makes only sense so we can print out on the server which IP address is actually connected, and actually when the player is doing some bad things to your server, I don't know, writing bad words in the chat, or is even trying to hack, you see his IP address, and then later on you can set up a IP ban, which then you can say you don't allow every connection on the server. You just say this specific IP address will get banned from the server and is not available anymore to, or not able to connect anymore to the server. So that's why we want to print out the IP address, so we know, okay, this IP address is a bad person. We don't allow any connections from that IP anymore. Okay, as next, we do need, of course, our public TCP client, which we call socket. This is our socket. This is our personal socket from the player. Each client who is connected to the server has its own personal socket. This is necessary to send data to the player at the end of the networking. So this is the most important part right here. So you know, okay, we don't want to send the information to everyone. We just want to send the information to this specific socket. That's why we want to load, or we want to save that specific socket. As next, we are setting up already for other videos. We are setting up a variable which is called public network stream. And we call this my stream. I think I already talked about it in the previous video. So basically how a network stream is working is it gathers all information in a certain amount of time, and then it sends all the information to the server. So for a little example, imagine this. So you send a package which is, for example, 100 bytes long, okay? We did set up, let's say our setup is 4096, which we did in the previous video. So our setup is 4096 bytes. And a network stream call is around, let's see, one call is around 0.001 second. So every 0.001 second, the stream is sending data to the client. So a stream call can be 0 bytes because you are not sending any information to the client. But also a stream call can be 100 bytes. Which basically means you are sending one package in around 0.001 second. You send one package and this is 100 bytes. But when you send, this is one packet, one network packet, but also you are able with TCP to send multiple packets at the same time. Okay, so what does that mean? The player logs into your game, and you basically want to send game information to the from the server to the client. So this basically means player logs into the game, and server sends following packages to the client. So the first package is basically, let's say, all items, one packet. The second packet could be all NPCs, one packet. Then it could be, I don't know, let's say the player inventory is also one packet. And let's say the player data itself. This means basically HP, health, mana, depending on the game you are doing. Okay, so I hope you guys can follow me a little bit. So you log into the server, and the server sends then all the information back to the client, so you are always up to date. So this all items, the package got a size of, I don't know, 200, no, let's say 2000 bytes, okay, because we have a lot of items. The NPC could have like, again, 1500 bytes. The player inventory got around 1000 bytes, and the player data got around 500 bytes. Okay, you are trying to send all of this at the same time. Okay, that's altogether it is 2000, 3500, 4500, 5000 bytes. All together equals 5000 bytes, if my math is correct. But we did set up that we only can send around 4096 bytes for each call. That means for us, we are sending 1, 2, 3, 4 packages, okay? 4 packages at the same time. Which basically means we have 2000, 3500, 4500. So it is getting sent in the first stream call. It is getting sent items. First send stream call is equal. So we are sending the items, which has 2000 bytes. Plus we are sending the NPC at the same time with 1500 bytes. And then we are actually splitting up our player inventory. Okay, so we have let's say we have 4096. In this case we have 3500, so which is equal to 3500 bytes. So we have, let me get the calculator. 4096 minus 3500 is equal to 596. Okay, so we have bytes left, we have 496 bytes. Which basically means that our player inventory will get split up. So we are sending only 500 bytes of our player inventory in our first stream call, which is actually pretty huge. Which means we can send and receive 3 packages at the same time, which will increase our speed of our network. And the player inventory will get then split up in 2 parts, which then gets sent in the second stream call. So the second send stream call is equal then player inventory, which is split up in 500 bytes. And then we are sending all the rest, which is then, let's say, player data plus player data, which has also 500 bytes, which then equals to 1000 bytes on the second stream call. Plus player inventory 500 bytes split. Okay, so which basically means those 3 are getting sent in one stream call in about 0.001 second. And at exactly the other 0.00 second, the rest of the data will get sent. That's why we are using a network stream. You only can use network stream with TCP because that's how it works. But now you get a little insight on how a network stream is working properly. So you can increase also the size, which we did set up on our server TCP, that the amount of data will get sent, that the amount of data is bigger, which you want to send, but then that causes also a lot of traffic. Also, if you want to decrease the size of the bytes which you want to send for each stream call, your traffic will increase as well. So you need to hit the perfect middle, which is for me like the 4096. I tested a bit around, and that's actually the perfect stream call for me to send a large amount of data in the best efficient way possible. And yeah, that's how it works. Actually, I hope you did understand a little bit what I'm trying to teach you, how the network stream, how TCP, how IP protocol is actually working. And so you can build up on that and move on with your personal package making. But don't worry, we are also cover up this topic in other videos. So we have done that. And as next, we do need actually a private byte array, which is our read buffer, which we just call read buff. Our read buff is actually our buffer where we are receiving and storing all the information we are getting from the client on the server, if that makes sense. So our stream, our network stream, is gathering all the bytes over the network, and then is getting passed into our byte array, our read buffer, so we can read out the package, which stores all the information. And yeah, I would say that's it for all the variables. As next, we are creating a new method which actually starts the client itself once he is connected. So we are going to create a public void, and we call this start. Simple as that. We do need to set up our socket again, like we did on the client, because the stuff we did on the client right here, we do need to make on the server as well, because every client is personal and specific for the player who is connected. So we are saying socket send buffer size is equal to 4096, like we did set up on the server. And then our socket receive buffer size is also equal to 4090 96. There you go. As next, we actually want to make sure that our MyStream is actually gathering data from the network. So it listens to the specific socket. Okay. So our socket, our server TCP client socket is specifically listening on our client, which is connected. That is his purpose on the server. So therefore, we are going to say MyStream is equal to socket.getStream, which allows us to only listen to the socket of our connected client, our specific connected client, and he only gathers the information from this specific client, which saves up a lot of resources and a lot of performance on our server. Okay, as next, our read buff. We need to increase the size of our read buff is equal to new byte array, which is actually 4096, which makes sense, right? And then we actually can say that we are start listening on the stream, so we get all information the client is sending out to the server. So we can say MyStream begin read. We do need a buffer, which is our read buff. We do need an offset. We are always starting to read out the information at position 0. We do need a size, which is actually our socket receive buffer size. And then we do need a callback, which actually is getting called when we are getting data from the server. And this method is getting called. Then we can read out the information, and then we can make a lot of stuff. So we are going to create our callback first. So therefore we are going to say private void, and we call this on receive data. We are using asynchronous sockets. So we are going to say async result, and we are saying result. That's our callback when we are receiving any information from the client on the server. So we are going to say on receive data, and our object state will be 0, also null, because we don't have an object right there, because our object is our client itself, our class. Okay, on receive data, we need to make sure that we make a try catch block. To make that, I type in try and then double hit the tab key to make the try catch block pretty fast. And why we are making a try catch block? Because when we are receiving no information from our client, which is also if the client is not connected anymore, then the whole instance of the client will close down. And if there is an error, we don't want that the server crash. Okay, we only want that only this socket will get closed. So the connection of the player will get closed and not the whole server will crash. That's why we are making a try catch block. Okay, so to receive data of the network, we need to create an integer. So how do we send data over the network? You need to understand how the sending over the network is actually working. That actually works like this. In example, you want to send your level. Okay, you are player 0 and your level is, in example, level 100. So this integer is getting stored in a byte array. This byte array will get sent over the network, and then this byte array has a certain amount of length. So your integer is 100, so it's length 100, and then your byte array is actually 100 size big, if that makes sense. Yeah, so you first of all need to read out how long your package actually is, and that's the way to go. So we are creating an integer which we call, in example, read bytes. and it is equal to my stream dot end read. We are stop reading the stream because we got a package from the client, and we are passing in the parameter of result. And now we have the package size which we are sending from the client to the server. But so we need to make sure that we are going to check if the package size is actually a package size, because even when you are connected to the server, or when the client is connected to the server, you are sending, of course, information. Okay, there's always there will be always traffic between server and client, even when you're not sending any data. But if you're not connected anymore, then your read bytes remain 0. So we are making a check. So if read bytes is smaller or equal to 0, then you are not connected to the server anymore. Client is not connected to the server anymore. And then we can say return, because we don't want to execute the code further, else we will throw out a lot of errors, which basically makes sense. We could also say we are going to close the socket on the server side, because you need to imagine when the player disconnects from the server, the socket on the server is still open. The server still thinks, okay, the client is not connected anymore, but the socket is still open. So another player cannot connect to this socket or take over the socket. That's not working. So that's why we need to say we are closing the socket, which we are going to add in a second. Okay, but if everything is correct, so we are getting any data, and then we can say, or we are creating a new byte array, which stores all the information from our stream, which we are sending. So we are going to say byte array, we call this new bytes, is equal to new byte array, and the length of our byte array will be our read bytes, because we know the length of our packet, and so we can resize our byte array, which stores then our information to the perfect size. So we can say read bytes. That's it. After that, because we don't want to hard code anything, we are going to say buffer.blockCopy, which copies a specific number of bytes from a source array to an array which we want. So we want our destination, or our source array is our read buffer. If you remember, read buffer is our source array. You will see why. We are starting always at 0.0 when we are reading out an array, and our array destination will be our new bytes, okay? Because we have resized our array, which we want to store the data, with the perfect size from the information we got from the client, which then fits in perfectly, so we don't have any empty spaces in our array. So we can read out the full array directly without looping through this array and sorting out the empty spaces. The offset is again 0, and we are counting. Basically, the count is our length of the byte array. This is our read bytes, which makes sense, right? Once that is happening, we can say we can handle our data here. But this we are going to cover up in another video, because this is a pretty huge topic, which takes time to understand. But for now, I'm taking here a comment, so I know, okay, here we are going to handle the data. So what happens here basically is we are going to handle the data from our connection ID, and we are passing in the information from our new bytes right there. That is what is going to happen. And after that, once everything is done again, we got one package, okay? But then we want to receive even more packages. That's why we are going to more packages from the player. So we are copy and pasting it right in here, and that's it. Also, if there is an error going on right here, we can say close socket, which we are going to add right now. So when we want to close the connection of a specific player, we can call close socket. So what is close socket? Well, this is a method we are going to create right now. So this is a public void, and we call this close socket. So what does this mean? As I already said, when a player disconnects from the server, he's not connected anymore, but the socket still remains on the server. The socket is not closed. So when you have like 1000 people connecting to your server and all 1000 will disconnect from the server, all the sockets on the server still remain. So the server still thinks, okay, there are still 1000 players on the server, and new players aren't able to connect anymore. So that's why we are going to say socket equals null, which basically nulls our socket, which basically then is, well, actually we can say socket.close. We are closing the socket of the player. We set the socket to 0, to null, and we could say, we can print out on the console that the player was disconnected. So we can say console write line, and we say connection from our object 0. Come on, 0 has been terminated. Our object will be our IP address, as you remember, which we store right here. Okay, why we are saying socket equals null? This has basically a good reason, which you will see right now. Okay, so our client class is pretty much done, besides our handle data, but that is coming up in the next episode, because this is again a pretty huge topic. Okay, so we are going back to our server TCP, right? So we have basically created our client class, but now we want to create an array of our clients. So we have I don't know, we can set up a maximum amount of players, okay, for the server. So we can say public clients, we hit the array sign, public clients, we call this client is equal to new clients, and then we can set up a number there, how many clients we actually want to have connected on the server. For that, we are creating a constant. So a constant is a variable which remains always the same number and which you can access from anywhere. So we are creating a public const int, and we say max players is equal to 1000. Okay, we allow 1000 incoming connections to the server. So we passing in our max players right there. Now we have 1000 instances of our clients. So there are 1000 unique clients which are able to connect to the server. Okay, now here's the thing. We have received the connection from the server. Okay, good. So we can say for int I equals 0, that's correct, and I is less than max players, I++. So what that means, it loops through all the 1000 players in this array. It loops through, and we want to check if there's an open slot available. Okay, and if there's an open slot available, we assign the incoming connection to this specific client, and then he is connected probably to the server and are able to communicate. So first of all, we are checking, so if client, our index I dot socket is equal null. Okay, now you got it. So if the socket is equal to null, then it means, okay, the socket is free, the spot is free, and this player is able to connect and take this place over. So if the socket is null, that's why when the socket disconnects from the player, when the socket disconnects from the server, we want to make sure that we are closing the socket properly, okay? And always set the socket to null, so another player is able to connect to the server. Then we can say client I.socket is equal to client. Simple. Then our client I dot connection ID is equal to our index, to our loop. So we know, okay, this is player 1, this is player 2, this is player 3, and yada 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 yada. As next, we want to make sure that our client I dot IP address is equal to client dot client dot remote endpoint dot toString, as we did on our console write line right here. But now we store the information in our client class. Perfect. As next, we want to make sure that the client will start. So we say client I dot start. Simple as that. And now we can say console write line connection received from, instead of making this, we can say client I.IP. Awesome. That's basically it. Okay. So now we are able to specify a specific client on the server. And now we are able to test that. So we are starting the server right away. So at let's hit start. Okay, initialization complete. And now we are going to start the client. Let's see on my debug folder. There you go. And what now should happen, we should get an error. You may ask why you are showing us an error. This is the most common mistake everyone is doing. Okay, so I show you. When we are starting the client and connecting to the server, we are getting a huge error. Boom. Client, excuse me again for my German on my Visual Studio, even though it is in English. It says our client array remains 0. Okay, so when we hover over our client, that is a hard sentence, we see all our clients remains null. And why is that? Well, this is pretty simple. We have created 1000 clients, but we didn't actually make an instance of this client class, if you know what I mean. Okay. The way to do that basically is, as you remember from the previous video, we want to initialize all game data arrays. Okay, so to do that, basically, to make sure that the array not remains 0 or null, we are creating a for loop. So for double tap, and there you go. So again, for int, then we say server TCP dot max players. In this case, we can say then server dot client I is equal new clients. This basically means that we creating 1000 instances of our client class before the server even starts, which saves us again a lot of resources, and actually people are able to connect. That's it. We can hit a comment here. So initializing game arrays, an example. So we hit start, we're initializing our game arrays, and now we can say game client, we open it, and what happens, as you can see, now we are flooding the server. We are saying connection received, like, let's say 1000 times. Why is that? Don't worry, this was on purpose. And now you see again, connection from has been terminated because we have closed the client properly on the server right there. Connection has been terminated. But yeah, now you may ask, why is that 1000 times? Why not only once? Well, the answer is pretty simple. We are looping through 1000 clients actually. And if we are actually hitting an open slot on the server, we hit the return key. Then we are only executing the command one time, assigning the player to one socket, and then we returning the for loop, and it says stop the loop, the player is assigned. So now when we hit start, open up our game client, what happens now? One time connection received from blah 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 blah. When we close the client, what happens? Connection from our IP address has been terminated. Simple, right? And now we can actually add another information. We can say connection ID is equal to our second parameter. Our object will be then I. Oh no, we can say client I dot connection ID. Okay, good. So we hit start. What happens now? Game client connection received from our IP address, connection ID is equal to 0. Why 0? Array starts always at 0, never on 1. When we open up the second game client, what happens now? Connection received from connection ID 1. The third client, connection ID 2. The fourth client, connection ID, connection ID, okay, this is strange, connection ID 3. And now we can close every single client by just closing the console application. Simple, right? And pretty cool. And basically, that's how you're going to create a multiple client server. What is the benefit of that? Well, basically, you can every client has its own thread on the server, which basically means every client, you have to imagine you have a powerful root server with, I don't know, 60 cores or something like that, and each specific client has its own thread, which basically means the server does not lag when you have, like, let's say you have 5,000 players on the server and every player is walking around, and that's a lot of traffic and a lot of working on the server. But with the multi-threading, you are able to keep the server clean, even though there's a lot of stuff going on, because every player has its own thread. And that basically means when a player is lagging out, for example, all the other players still are normal, you know, on the server. That's basically the very basics of an MMORPG server like World of Warcraft is using. But also you can build up from that to create basically your very own and better threading system to make the server even more efficient if you want to. And yeah, that's, I think that's basically it. We created our client class. We make every client unique with its own connection ID, and basically we are assigning an array. You could also use list instead of an byte array. So you could say I don't know, public list. Wait a second. We do need using system collection generic for that. So you could use list, player list of, I don't know, clients in example. And then you could say player list is equal to new player list. So to new list of clients, there you go. And then you could say then player list.add, which is pretty simple. I'm passing in the client, so you don't have to resize the array, an example. But arrays are pretty fast and pretty easy to use, and I would stick to that and that system, and then you guys are actually good to go. So I hope you have enjoyed this episode a little bit. I hope you took enough information to already create your multiple client game server and how to connect with the client to the server. And yeah, on the next client, we are actually covering up how to create your own packet buffer, which basically means how to create a network message and then how to send it over the network. That is our next step. And then we're actually going to create a little chat system with multiple clients and with a little command on the server where you can kick a specific player from the server. And yeah, thank you guys for tuning in. I hope you liked that. If you want to message me, you always can hit me up on my Discord channel. You can hit me up on my Facebook page or even write me here on this side a private message, and I try to answer you as soon as I can. Again, thank you for watching. Take care. Good luck in your project and see you guys soon in the next episode. Thank you and bye. Hello everyone and welcome to the next episode. This episode will be a little different from the others because we are preparing the next episode because we are going to create a DLL file which allows us to implement anywhere where we want. In example, if you are using Unity, as example, you can implement this DLL file into Unity, and what this DLL file does is following. So as we know from the previous video, sending data over the network happens with a byte array, okay? And to make sure that you want to send multiple information, as example, a string, an integer, a float, a short, a long, whatever you want, within one network package, you can basically create a string for it, convert the string into a byte array, and then send it over. But developers are very lazy people, at least I am, and that's why I'm going to create a byte buffer, a so-called byte buffer, which then does everything automatically for me. So writing data into a buffer, send it over the network, and the same way as reading the data. And the benefits of creating such a file is basically during the development process, when you are creating an MMORPG, for example, you have, like, let's say around 100 to 200 different packages which get sent back and forth between the client and the server. And every package is unique with its own information, and you don't want to write the same stuff over and over and over again. Of course, you need to write same stuff, but not that big of an amount when we are creating our byte buffer class. And what the byte buffer class is in specific, we are going to see right now. I'm going to learn you how to create our own byte buffer, how to use it, and how to make it then work with the networking. Awesome. So before we start, we are going to create a new project within our solution. So we have our game client, we have our TCP server, and what's next is we are going to create at first a project, and then we are going to create a class library. This class library we are going to name byte buffer. We are going to use the latest net framework 4.6.1 because we are not using Unity. If you want to implement this DLL file in Unity, you can use this byte buffer as well as for UNet or Photon, for example. That works really great, but then you have to switch to net framework 3.5. I don't know the current version of Unity is using the newest net framework. You need to check that, but for this example we are going to use net framework 4.6. Awesome. Create this project. I already have created this project. The reason is because I have recorded this video before, and it actually didn't record the sound for me, which made me pretty sad, but I'm here again recording from the beginning for you guys. So let me fix that really quick. I'm going to open. We have the byte buffer here. We have the bindings, which we are creating as well in a second. Okay, so add new project, class library, and we call this byte buffer. All right, so we have our byte buffer, and what we are going to do first is we are going to rename our class1.cs into byte buffer.cs. The reason why we are doing this, and also hit yes, because you are getting asked, you are renaming a file and you want to rename it for everything, and you say yes. Okay, so why we are doing this is because we want to call, when we implement this DLL file into our server, we want to call our byte buffer like this: byte buffer buffer equals new byte buffer. That's how we call or creating a new instance of this class. But that's not going to happen. What we have to do is to make a byte buffer dot byte buffer. But we don't want to do this, okay? That's why we are going to remove the namespace, and then we are good to go. As you can see, byte buffer buffer equals new byte buffer. Perfect. The next what we need is basically a few using directives. So we can remove link queue and we can remove threading task, but we do need collections, generic, and system.txt. Okay, so before we start, we need to make sure that we understand how packages, network packages, which we send over the network, are working. So you only can send a package over the network as a byte array. Okay, we got that. So let's make a comment. Let's see. An example. There you go. Send packet as a byte array. Okay, we got that. Then we want to add multiple information, like a string, as I said, like a string, integer, and also a byte array. We want to add a byte array into a byte array. If you want to send more data than just a single one. Integer, as I said, float, shorts, and stuff like that. So add multiple data into one package, like string, int, short, float, byte array. Yeah. Okay, so but we cannot do that in a byte array directly. So how are we going to do that? So we have to think, what is the best fit to convert everything, like a string, int, short, float, byte array, into something which then can get converted into a byte array. And that is pretty simple. We are going to create a list of bytes, because everything single one of that is 1 byte, okay? A string can be converted into a byte because it is a byte, right? A int can be converted into a byte. Everything is a byte because bytes are the computer language and everything is built up on bytes. And you can basically easily convert a byte list into a byte array. That's pretty simple, and that then can get sent over the network. Great. So what we are going to do, we are going to create private list of byte, and we call this buff. This will be our buffer. Every time, as I already said, every time we send or receive a package, we want to call this byte buffer class. Therefore, we need to create every time a new list. So we are reading the data from the list, or we're writing the data from the list. And that causes a lot of trouble in your resource memory. There will be so much memory used, because imagine you send 1 million packages in about 1 minute, which can easily happen. and then you have like 1 million instances of this byte buffer class. That will cause a lot of trouble in your server performance, in the client performance. Your player will be unhappy because the usage of memory will be that big. And don't worry, we can get rid of that. For that, we are going to use an Windows implemented interface. To implement an interface is after your public class byte buffer, you hit that double point, and then we are using idisposable. Don't worry when idisposable will print out an error, because we have to implement this interface properly. And what idisposable is doing, basically, it gets rid of the trash memory usage, which basically means once you're done with the byte buffer class and it is not getting used anymore in any way, the idisposable is removing it from the memory. So you always have more space, better performance overall, and your memory will not get dumped into useless stuff. And to implement the idisposable basically is pretty simple. We just need to add, let me create a region, because I want to make this code very clean, because it's going to get a pretty long code. So we hit the region, so type in hashtag region, double tap, and then it gets created automatically. We call this region idisposable interface. Okay, within this region, we are going to create a private bool. So we are going to create a private bool and call this disposed value equals false by default. So what is disposed value? Why we are going to use it? Well, we are going to use it to detect random calls. Okay, so let's make a comment here. Detect random calls. Okay, as next we are going to create a protected virtual void, so we can call it and overload it. So we are going to create a protected virtual void, and we call this dispose. And what do we need? We do need a parameter of disposing. Okay, and what is disposing is doing, the bool, you will see in a second. First of all, we are creating an if statement and checking if the disposed value is equal to false. So we are saying disposed value equals to false. You can use a double equals, or you can just get rid of that and hit that sign right there. That means if disposed value equals to false, then we are going to make another if statement and asking or checking if we are disposing. So if we are disposing, then we are going to clear our list. Okay, we are going to clear our list because we don't need that anymore. So we say buff.clear. And as next, we want to make sure that we are starting again at position 0 when we are reading out the next package. Therefore, on the very top, we are going to create a new private int, and we call this read position. Position, there you go. And then we can say buff clear and then read position equals 0. Our read position therefore is for when we are reading out the list, so we know, okay, we read the first information out, we get the length of the first information, then we can move on to the next information, and so on and so on. So after this if statement, we are going to say disposed value equals to true, so we know, okay, we are disposing it and everything is good to go. But still, we do have idisposable as an error. Therefore, we are going to create our overload. So we are going to say public void dispose. Okay, not disposed. We are going to say dispose. And what happens right here is that the error should go away, because disposable is an interface, and idisposable, when you implement it, you need to have your public void dispose, else you cannot implement idisposable. That's how interfaces works. And now we can overload our dispose right here. We can say dispose equals to true, So we are getting rid of the trash memory in our system. And then we can say gz dot suppress finalize. And then we want to remove this from our memory. There you go, this instance from our memory. Because we are creating a lot of instances of this byte buffer class. This will be the main class of the networking. Okay, great. Now we have created that. We are ready to go. And now we can create our byte buffer itself. So as I said, every time you want to create a new instance of this byte buffer, you want to create a new list, and you want to start at position 0. And you don't want to type it every time you create a new instance. Therefore, we are going to create a public byte buffer. Okay, that means every time we call a new instance of this class, and this method will get called automatically. Then we can say buff equals new list of byte. And then our read position equals to 0. That's simple. As next, we are making a few functions so we can check how long is our list, how many items we got in our list, where we are reading at, and actually convert the list into a byte array to make it fit to send over the network. So therefore, we are going to create our first function, which is public long get read position. Our read position, we can say return read position. That's it. As next, we want to convert our list into a byte array. Therefore, we're going to create a public byte array, and we say to array. Okay. And what we are going to do is we are returning our buffer.toArray to convert it. As next, we want to count how many items we got in our list. Therefore, we're going to say public int count, and we are returning buff.count. As next, we want to make sure how, or we want to know how long our byte is, our list is. So we say again public int length, and what we are returning our count, how many items we got, minus our current position we are reading the buffer out from. And as next, of course, we want to clear our buffer. Therefore, we are going to create a public void. We call it clear. And what do we want to clear? We want to remove everything from our list. Therefore, we're going to say buff.clear, and read position equals 0. Perfect. Now we are perfectly fine prepared. We are going to create a region right here. So region, and we call this byte buffer functions in example. Then we can drag and drop that into the byte buffer functions region, and our code looks really clean. Okay. Now we are getting to the interesting part. We want to write information, as example string, ints, shorts, longs, byte arrays into our list. But to do that, we need to convert them first, okay? And so we don't need to convert them every time we writing a new package. We're making it automatic, so everything is working automatic. Okay, so to do that, we are starting with an integer. So we are creating a new method. We call this public void write integer, and we are passing in a parameter, a int, and we call this value. Because we are calling this function, this method write integer later on when we want to add an integer into our package, and then we can pass in our value. And now we can add it to our list. So we can say buff.addRange, and then we are using the bit converter to convert our int into a byte, which then says bit converter.getBytes, and then our input value, excuse me, but we are going to rename it. Instead of value, we are saying input, because it is the input actually. Input. There you go. Okay. And then we want to make sure that our list, which we have added, that it is getting updated. So we know, okay, it is getting updated. So we don't remove it from the list. Because later on we are run into troubles when we are reading out and writing data into a list. That's why we make sure we are making a bool first, which says then, okay, update if we are updating the buffer or not. So therefore we are going to create a private bool on top, which is called buff updated equals to false by default. And then we can say after at range, we say buff updated equals to true, because we are updating our list. Great. As next, we want to add, let's see, a byte array into our list. So we are going to say public void write bytes and a parameter of a byte array, and we call this input. And how to convert a byte array into a byte is actually pretty simple. We just say buff.addRange and we call input, because a byte array is nothing than a byte, right? Multiple bytes. And then we can say buff updated equals to true, and we are done. As next, we want to write a float into our list. So we say public void write float. We do need a float as a parameter. We call it input. And now we can say buff.addRange. Again, we are using the bit converter because the bit converter is converting everything into a byte. And we say again get bytes, and we are calling our input. And again, buff updated equals to true. Perfect. As next, we want to make, we have a float, then we are taking a long. So we say public void write long. We do need a long of input. And again, we can just copy and paste this into our long. That's it. Then we want to make, we want to send a short as well, maybe. Then we say write short, parameter of short and input. And then we copy and paste it in again. And now the hard stuff. How we can add a string into our byte list. Well, before we do that, we need to make sure how we can do this. As you know now, we can write integers into our byte, but we cannot actually add a string, okay? So how we can do that, we need basically need to know how long our string is, okay? Because when later on we are reading the information out, we don't know how long our string is, so we actually cannot read it out properly. So before we are adding the string into the list, we need to add the length of the string into the list. So we know the length of the string, and then we can read out the string itself. So to do that, we are going to create again a new public void, and we say write string, parameter of string input. Okay. In this method, we are actually adding multiple stuff. We are adding again a buff at range, a bit converter. We say get bytes, and then we are actually getting the length of our string. So we are saying input length. So we know the length of our string. And after that, we are adding the actual string to our list. But to do that, we need to say at range. We cannot use the bit converter as we know, but we can use the encoding. So what does encoding do? Encoding basically converts your characters of your string, your ASCII or ASCII as I call it always, into bytes. Okay, so I'm encoding ASCII or ASCII CII dot get bytes, and then it automatically converts your string into bytes and adds it to the list. And then last but not least, we can say buff update. Buff updated equals true. We get a little error there. Oh, we said buff.add, but it has to be at range. There you go. Okay, buffer update too. Okay, basically we are now able to write a full package of a network message. And as an example, I show you that we are going into our TCP server into references right here, and add our byte buffer CS as a reference to our server, so we can inherit from this class. So we say add reference, we click on projects, and as you can see already, byte buffer, check mark it, hit OK, and now we can actually call our byte buffer class. Let's go into server TCP, and as an example, what you want to do basically is you want to create your first message. In example, a player logs into your account. The server wants to send the player information to the client, meaning player name, player level, gold as an example, and stuff like that. So to do that, we are going to create a new method. In example, public void send player data. The detailed part of the stuff we are covering up in the next video. But this is just an example how to call now your byte buffer class and how to create your package itself. So public void send player data. Now before we are writing data into our package, we need to create our package first. So we are saying byte buffer buffer equals new byte buffer. Perfect. But now we want to have a packet identifier, okay? So the client later on knows which packet is actually getting sent and what do I have to do to read it out. And to create a packet identifier basically is pretty simple. You can add a value to it, like a number. In example, and you always have to do that first, else the client or the server does not know which packet you actually want to send or you are receiving. So add the package identifier always as first. Okay, always at first. And how to do that is basically pretty simple. We say buffer dot write long, and then a packet identifier is always a number, so we say this is the packet number 1. Okay, this is the packet number 1. And after that, you can add all your information. In example, the player name, which is then buffer dot write, not write short, write string, and then you can add a string. In example, my player name will be Kevin Master 9000 in example. Then the player level will be buffer dot write integer, player level, I don't know, 100. And then we have a pet name, then we can say buffer dot write string again, pet name number 1, and oops, and then maybe your gold in your inventory, you can say then buffer dot write integer again. You have, I don't know, 1 million gold in example, and you can add as much information as you want into one package. And at the end, after you have added all your information, we can call the method send data, which we are going to add in the next episode. Then we can say, in example, send data to our connection ID to the specific player, and then we can say buffer.toArray, which then basically, as you remember, the buffer creates a new list. We are writing data into the list, and with buffer.toArray, we are actually converting the list into an array, which then gets sent over the network. And that's how you create a package, pass in values easily, and add it to a list and send it over the network. And after that, after you have done that, remember our idisposable, you can say buffer.dispose to remove the instance completely from the resource management system. And then you are good to go. That's how it actually works. Let me comment that out. That's how you send then data from server or from the client to the client or to the server. Great, but now how do we write or how do we read the package then out? So as I already said, you have the packet identifier, which we will cover up in the next episode in specific. And then we could actually, let me think. We have the packet identifier. As you remember, we are adding everything into a list and then converting the list into a by the way. And to read out everything, we basically have to make everything in reverse. So you are receiving a by the way, you need to convert this by the way into a list. And then the list basically you have to read out, and that's what we are going to do now. For that we do need a few functions, few functions, which then instead of writing integer, you're reading out the integer. Okay, and that's what we are going to do right now. But before that, a little side info. Since we are converting everything into a byte, different things have a certain length as a byte. So as example, an integer is a 30-bit variable, which is equal as a length as 4. Okay, as a byte. So one int is actually equal to 4 bytes. A long instead is equal to 64-bit, which is then double as an integer, which is then a length of 8 as a byte. And then we do have a short, as you can imagine, is a 16-bit 16-bit variable, which is then the length of 2 as a byte. And that is the information we definitely need for our next steps. Okay, so imagine, remember that. Okay, so we are going to create our first, or the most important function, which is actually reading out an integer. So therefore, we are going to say public int read integer instead of write integer. And then we do need a parameter, an optional parameter of bool peak equals to true by default, because the reason is later on we are checking a few stuff in our read string, which then we need to peak our package and then the integer, and then so we don't move to the next step in our reading process, if that makes sense for you. Okay, so to do that, basically we are creating, to read out the integer from our list, we are going to create a if statement. So we are saying if buff.count is greater than our read position where we currently at, reading out the package, then we are going to say if buff updated equals to true, then we can say read buff we do need a new variable. We need to create a temporary byte array. So we are going to create one. We are going to say private byte array, and we call this read buff. There you go. And then we can say read buff is equal to buff.toArray. And then we say buff updated equals false, because we are not writing into our buffer, we are reading into it. Okay, but if buffer updated not equals true, then we can say int value, because we can read out then the information from the list. We can say int value equals to bit converter. We are converting from a byte back to an integer. Remember, a int is a 32-bit variable, which then we need to convert back as a 2int32, which we then say from the read buffer, and then our start index is our read position. Okay, then we can say another if statement. So if peak and buff.count is greater than our read position, then we are moving on to the next information part. Okay. As I said, an integer remains for a byte as total length as a byte. Then we can say read position, our position plus equals 4. That is then our next information part, which we did add in our list. And last but not least, we can then say return value. So we are getting the correct value out of our integer. And then we can say else. So if there's an error, as example, we can throw out a new exception. So throw a new exception. Byte buffer is past limit. Make sure you are reading out the correct value. Okay, so what does that mean? As I already said, you are writing data in a certain position to the list. So at first you are writing a long, then a string, then an integer, then another string, and then another integer. And to read out this package, you need to read it out as the same order as you added the stuff to the list. So at first you're writing a long to the list. So if you then firstly read out a string, then you get the error, because the value between those two, between a long and a string, isn't the same. That's why you are getting error reading out the package. So when you add the long first as a package, you read out the long first. After that, you can read out the string, then the integer. So it has always to be the same order when you are writing. And when you're writing in a certain order, you have to read it out in the same order as you are writing. Damn. That's a lot of information, I know. Okay, but now we have the most important part, reading an integer out, done. As next, we want to read out a byte array from our list. So we can say public byte array read bytes again, but this time we need a parameter of int length, because we want to make sure, or we want to know how long our byte array actually is, and then our optional parameter of boot peak equals to true. Great. To be fair, we could actually, if I look at everything, we can basically copy and paste this part from if buff updated to our returning of our value. So copy this and paste it into our read bytes. But now we have to make a few adjustments. Instead of our int value, we are going to say byte array value. And now you can see our bit converter is getting an error because we are not converting a integer anymore. So remove this. Instead, we are going to say buff.getRange. Since it is a byte and we are getting a byte array, we don't need actually to convert it. So buff.getRange from our read position to our length, and everything we can say then to array. So we are receiving our byte array from our byte list. As next, we can remove this line, this if statement, and we are passing in another variable. So if peak equals to true, so just if only peak, then we can say read position instead of plus equals 4, we just say the length of our byte array to get the next position of our list. Simple, right? Great. As next, we want to read out a float. So we're going to say public float read float. And we only need the same as a integer, bool peak equals to true to make it optional. And that's it. And now we could actually, since a float is a single, it is the same as a integer, I guess. Then we could basically copy and paste everything from our integer into our float. And we are definitely good to go. Just a few adjustments. Instead of int value, we just say float value. And now we should get an error to int 32, which is not going to happen. But we are going to change it, our bit converter, since we want the commas between our numbers, since a float is something like that. Instead of to int 32, we are going to say bit converter to single. Read buff, read position, everything is cool. And we are done reading our float. As next in our list, we are going to read out a long. So we are going to say public long read long. Again, bool peak equals true. And then copy and paste everything again and make a few adjustments. Instead of int value, we are going to say long value. And as you remember, a long is a 64-bit variable. So we are going to change it to int 32 to int 64. And our read position plus equals 4, we are going to double. As you remember, instead of 4, it is 8. And we are done reading our long. As next, we want to read out a short, so the same stuff. So public short, read short, bool peak equals true, and copy and paste it. Instead of int value, we're going to say short value. Instead of bit converter to int 32, we say to int 16, as I just wrote it down. And instead of read position plus equals 4, we say read position plus equals 2. Done. And now we are coming, last but not least, to the bad string. That is a little bit more complicated. Because, well, actually not. Let me think. We are going to create a public string. We call this read string. And what do we need? We just do need bool peak equals to true. As you remember, writing the string, we are writing first the length of the string. So we are going to read out the string first with the length. So we are going to say int string length is equal to read integer, and we are hitting the optional parameter to true because we are only peeking. We are not actually reading, we are only peeking. And then we can say we are creating an if statement. Well, actually we can just copy and paste everything. So let's see. Going into short, we are copying if buff updated till return value. We are copying these. Passed it in. And now we are making a few adjustments. So instead of short value, we are going to say string value. And now instead of the bit converter, which does not make any sense, since we are using encoding for strings, we are going to say encoding.ascii.getString. And then our read buff, our read position, read position and then our length of the string, which is then our string length. And then everything is okay, but instead of read position plus equals 2, we are actually moving on with our string length, which then we're just passing in string length. String length, there you go. Oops. And I think we are good to go. We are now able to write data to the list, and we are now able reading data to the list. And I'm going to show you now a little example how that should look like for you. So since we know we are sending the player data, okay, with our packet identifier, and now we are covering up the handle data in the next video, but now when you receive the package, the client knows, okay, which packet it is, and you want to read out the information, then you have a little method like this. So public void receive player data. Again, you're getting a byte array. That's why you need to create a new byte buffer to write the byte array into the list to read it out. So you're going to say byte buffer equals new byte buffer. And now instead of writing everything into the list, you just need to write one time to a list. That's why you're going to say buffer dot write bytes. Okay. And now you always will have something like this, int connection ID and byte array data as a parameter, as you are not receiving any data later on. So buffer write bytes, okay. Now it is client side, therefore we can remove the connection ID then. It is just an example. So buffer write bytes, then you pass in the data in it. So the byte array then on your client is getting converted into the list, and then you can read out the list. So as we know, we have a packet identifier in our list. So we are going to say long packet identifier is equal to buffer.readLong. Simple as that. As next, we are getting our player name. That's why we can say string player name is equal to buffer.readString. As next, we are getting our player name, which we can say integer. So int player level is equal to buffer.read read integer. Then we are getting our pet name, which is then again a string, which says string pet name is equal to buffer.readString. And last but not least, we're getting our goal, which is again an int, which then we can say int player goal is equal to buffer.read integer. Now once you have read out the full package, then you can say I don't know, save player with all your values and stuff like that. And you don't have to forget that you have to dispose the buffer. And then last but not least. And that's how the server should look like, and that's how the client should look like later on. But that we are going to cover up, as I mentioned 1000 times, in the next episode. Awesome. I hope you did enjoy this little tutorial video. As I also already said multiple times, you can use this byte buffer, which is a pretty awesome thing. As you can see, you can easily write data into a package and read it out without any hard coding stuff, something like that. Yeah, you can use it in Unity, you can use it in Unreal Engine, in C++ application, in Visual Basic applications, in Ruby applications, Auto IT, if that is still a thing. You can use it anywhere you want, and you can implement it. Since it is a DLL file, actually we can create a DLL file. So right click on byte buffer, build, wait till it is succeeded, right click on byte buffer, open file in File Explorer, go to binary, debug, and then you have your DLL file there, which you can implement anywhere you want. And yeah, that was a little preparation video for the next episode, which we need to move on further in our tutorial series. And yeah, I hope you learned a little bit about variables and how, well, got a little insight how packages are actually getting sent. And yeah, I would say thank you for watching. Take care. Good luck in your projects. Have fun in your coding. And hopefully we are going to see us in the next episode. Thank you for watching and bye. Welcome back everybody and welcome to the next part. Yeah, today it is getting a little bit more interesting than the last part, because today we are going to create our sending method and our handling method, and we are going to send our first network message from the server to the client and backwards. Yeah, I hopefully you have followed my last part very carefully, because you will need that information pretty much to continue further. So that was from the last part, which I can delete because we don't need that. And yeah, today or right now we are going to create our first method, which actually sends data over the network to a specific player. Great. To do that, we are going into our TCP server project in our server TCP, and we are going to create a new method, a new private method, which we are calling private void send data to. So private void send data to. And we do need two parameters because we want to send a package to a specific player and not to everyone. We need to pass in a parameter of the connection ID from the player. So we passing in int connection ID, and of course we do need the package itself, which we are going to create within another method. And then we are going to say byte array data. Perfect. And now we need to make sure that when you are sending multiple data at the same time, that the client does not lose track of the packets and drop them, if you know what I mean. So that happens a lot of times when people without knowledge creating a network, a basic network from I don't know, free source codes, and then they wonder why when they send like 10 packages at the same time that only 2 arrives. That happens because you don't have a packet loss prevention. The way to do that basically is you create a package inside a package. Okay, so the package contains that we are going to create a package that contains the size of the package which is in the package. if that makes sense for you. Okay, so I stopped trying to explain. I will show you what I mean. So when we send data to a specific player, we are going to create a new byte array, a new byte buffer, which we are going to call buffer equals to new byte buffer. And now we want to add information to this byte buffer. We want to make sure that we send the length of the network package which we have created, so the client does know how long the package actual is, and so he keeps listening to the network till he receives the full information of the package from the server. And we could basically just say buffer dot write integer and data dot length, and you would think, okay, that is the packet size, but that is wrong. That is totally wrong. What we need to add to make sure that we don't lose the packets in the network, or so the client does not drop the information, the package information, we are going to add a write long, because as I already said, you want to make sure that you send as much data as possible in one network call. That's how TCP works. So we are taking the biggest size which is possible, which is a 64-bit, which is a long, and now we are basically doing some math. We are getting the upper bound and the lower bound of our byte array data and divide it and then make a +1, if that makes sense. I don't know how to explain this, but that's how it works when you want to make packet loss prevention, which is basically therefore you also are covered about packet flooding and sniffing. So this is not only a trick where you let's say prevent a packet loss. This is also that people cannot read out the packet itself and manipulate it. Okay, this is some kind anti-hack shield or something like this. But okay, so we have a buffer write long, and again open brackets and close brackets. Then we say data dot get upper bound and the dimension of 0 because it is one dimensional minus the data dot get lower bound. Okay, so that basically means we are getting the first value of our data and the last value of our data. Okay, also our first value of the data minus our last value of the data, and that everything together +1. If we are coming to the handling data, you will understand why I'm doing this. Okay. As next, we are writing our package into our package. Okay, that makes sense. So we say buffer.write bytes our data. And now we are coming to the function where we actually send the packet over the network. Okay, to send it over the network via TCP listener, this is pretty simple. As you remember, we have created a client class right here, clients, and we are using our socket and our stream, our personalized stream and socket to send the information to the specific player. Okay, so we are going to say client, we are passing in our connection ID dot my stream dot begin write. So we are starting writing the data to the network, to the player itself, and then we need to pass in our byte array, our buffer, and that is our buffer dot to array. Okay, our offset is always 0, and our size is our buffer dot to array dot length. We don't need a callback when the package arrived on the client side. Now you could do a callback which says then, okay, the package arrived on the client side, but that is just nonsense, right? So we don't need that. So we pass in the parameter of null, and we also don't need an object state. So we are passing in a null as well. And that's it. This is our method where we are sending data when we are creating a package. And how we are going to create a package is following. So this is our send data to, and now we are creating a region. So hashtag region, double tap, and we are going to call this region send packages. An example. Okay. Now we are going to create a public. Can we use static? Public static void. Let's use a public void. That's okay. Public void send welcome message. We do need a parameter of our int connection ID because we want to send the welcome message to the person which is newly connected to our client. Okay, so we say public void send welcome message, a parameter from int of our connection ID. And now we are going to set up our first network package. We are going to say byte buffer equals new byte buffer. We need to pass in our packet identifier. So we are going to say buffer.writeLong 1, which is our packet identifier. But what we are going to do right now is following. We are going to create a new project. Okay, so right click on your solution, add new project, and we are going to add a shared project. A shared project is you can add it as a reference in different projects, and the code on the shared project will be available on both projects. So if you change the code on the shared project, it will automatically get changed, in example, on your game client and on your TCP server. We call this shared project bindings. Hit OK. And we are going to reload the solution. We say yes. Okay. We right click on bindings and we add a new class. We call this class, simple as that, packets. We add this packets and then we are going to delete everything in that. Okay. Now, we have server packets and we have client packets. The server packets are getting sent from the server to the client, and the client packets getting sent from the client to the server. So therefore, we are going to do both client and server packets. As you see in our server TCP, our packet identifier is a number, a long, a int, a byte, or whatever, but we are using a long. So therefore, we are going to create a enum. A enum basically is, well, numbers in names, like that. So we are going to create a public enum, and we call this server packets. And now we can write a name, which is then automatically converted into a number. In example, I always make server packets. I give the server packet a name and add the S before the name. So I say S welcome message equals 1, comma. And then the client packet, same public enum client packets. Okay. And we say C for client, and then we say thank you message equals 1. So the reason why I'm doing this is when you have an MMORPG, you will have a tons of packages. Then it can be getting confused when you write in numbers. That's why I'm giving the numbers a name, so I know, okay, this is the welcome message, and this is the thank you message, and whatever. Now we are adding our bindings project into our TCP server. So click on TCP server reference. Right click, add reference, and now you see shared project, and you can check mark bindings and hit OK. Now you have your packets combined, your bindings combined with your TCP server, and now you can get access to the enums. Great. Now we can remove that. Let's remove everything. Okay, TCP server. Now instead of writing down the number 1, you now can say server packets dot as welcome message. And as you can see in the info bar, server packets dot as welcome message equals to 1. That's your number 1. And now you are getting an error because it is a byte, and you need to convert it to a long. And to do that, you just type in long before the server packet, and everything is good to go. Perfect. Now we have added our packet identifier, and we are ready to send the information which we want to send to the client. And yeah, let's add, for example, the welcome message. So we say buffer.writeString and welcome to my game server. Make sure to check out the forums. In example, this is a example welcome message, or welcome to my game server. You are connected to world 1. Let's say it like that. Okay, now we have two informations in our buffer. First the packet identifier and then our welcome message. Okay, and now we can call our send data to. So we can say send data to our connection ID, which we have as a parameter, and then we can say buffer.toArray. Perfect. That's it. And don't forget buffer.dispose. Same as right there in our send data to buffer.dispose, and boom. Now actually, when a client is connected, okay, we are getting the message, okay, connection received from blah, 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 now he is connected. And after that, we can actually send directly our welcome message to the client. So we can say send welcome message to our connection ID, which is then our client i.connection ID. And now we are sending this message to a new connected player on the server, which is awesome, right? But now we need to handle the information on the client side, which is a little bit tricky. Yeah, okay, let's go into our game client. Let's close the server TCP. Let's go into our game client, and we are going to create directly a new class. And this class we are going to call client handle data. Okay. We can delete those three. We only need using system and system collections generic. This is going to be a public class. Okay. Of course, when you send data from the server to the client, you will receive it, but you are not listening to the specific package you are sending, okay? Therefore, we need to make sure that the client always listens to the package which we did set up on the server. That's why we have created a shared project, so the client always listens to everything what is the server packets. And let's add it as a reference first. Oops, not byte buffer. Game client reference at reference bindings. Okay. To listen to all the package which the client, which the server is sending, we are going to create a dictionary. Okay. To use a dictionary, we do need a delegate. Which then basically means we are adding every package which we are receiving, we are adding a method to. That's why we are using delegate and a dictionary. So in example, when we are getting the packet as welcome message, then we already did assign on as welcome message a certain method which will read out the information automatically of the as welcome message. I will show you what I mean. Okay, first of all, we do need a byte buffer as well in our game client. So at reference projects byte buffer. Okay. First of all, we do need a variable, a public byte buffer, and we call this player buffer. Then we do need a private delegate void. We call this packet underscore. And we do need a parameter of byte array and data, which will be our byte array, which will be our data, which we receive from the server. And then we are going to create a dictionary. So dictionary, our key will be a long, because our package is a long, our package identifier. And then the value will be the packet itself. And we call everything packets. As next, we do need a private long of packet length, and we call this p length, to know how long our packet actually is. Okay, Before the start of the client, we need to assign every single package its method. Okay, we need to listen to everything. So therefore, we are going to create a public void, and we call this initialize packets. We make sure that we print out what we are doing. So we say console.writeLine initializing network packets. Yeah. Then we create a new dictionary. So let's say packets, a new instance of our dictionary, excuse me. So packets equals new dictionary long packet. And now we can say packets.add. Now we are adding all our packets into our dictionary so we can listen to them. Therefore, we are going to say packet long. Then we say we just have one server packet. So we say server packets as welcome message. And then we need to assign a delegate, a method to it, to this package, which then automatically gets executed when the package arrives on the server. And this method we are going to create right now. So we are going to create a private void, and we call this packet underscore welcome message. And we need to pass in a parameter of byte array as we did set up in our delegate. So we say byte array and we call this data. Now, in our packets add, when we, after the comma, we now can add our packet welcome message. As you can see, it will be automatically be there. So double click it and now it is assigned. So every time now the client receives the package as welcome message, this method is getting executed automatically, which is pretty awesome, right? And now how are we going to read out the package itself? So as you remember, we are calling the buffer, byte buffer equals new byte buffer. Then we are saying buffer.write bytes our data. And then we can read out the packet identifier. So this is a long, so we can say long packet identifier is equal to buffer.readLong. And as I remember, our welcome message just has one string, so we can say string message equals buffer.readString. And then we can print out everything. We can say console.writeLine. And we pass in the message, which then is our server message. And then don't forget buffer.dispose. Okay. But now actually how we are receiving our packet. There's no method where we can receive our packet. And that is what we are going to do with our packet loss prevention. Good. So we are going to create a new method, which is the most important method ever to receive any data. So we say public void handle data, which handles our data. We do need a byte array of data, which is our packet. And now we are going to create a new byte array, which we are going to call buffer. And then we are not hard coding anything, so we are cloning our data into our buffer. So we say buffer is equal byte array data.clone. We are cloning the information into our temporary buffer. Then we are making a check. So if player buffer is equal to null. So if you don't have a byte buffer yet, so our player buffer equals to null, then we say player buffer is equal to new player buffer. And then we are actually writing down the packet, which has the packet length and the packet itself. Okay, as remember, we have a packet within a packet. So we can say player buffer dot write bytes our buffer. Okay, Now we need to make a few checks to make sure if the packet is the actual packet and not a fake thing to flood the server or something like that. So we're making another if statement, which actually says if player buffer dot count, okay, equals 0, then we can say player buffer dot clear and return, because we did not receive a proper package. After that, we are checking if the package actually has a packet identifier, okay? If we have assigned a packet identifier, else we are getting a lot of troubles if we by packet, and therefore we are going to check it so the client won't crash and stuff like that. So we are going to say if player buffer dot length is greater or equals to 8, we can say packet length equals to player buffer dot read long, and we are saying false because we are not peeking, we are just checking. And then we are checking if p length is less or equal to 0. Then we can say player buffer dot clear because the package is not a proper package, and then return length. Okay, good. Some security checks, and now we are actually receiving the packet and add the packet loss prevention directly in it. So we are making a while loop. We are listening to the receiving package till we gather the full information, and then we are receiving the next package. So we are going to say while p length is greater than 0 and p length, packet length, is less or equal than player buffer dot length minus 8, because the packet identifier, remember, it's a long, it's the number of 8. Then we're checking if p length is less or equal than player buffer dot length minus 8, of course. And then we are checking player buffer dot read long. We are actually gathering the full information of the packet size. Then we can say data equals player buffer dot read bytes, and then we say int and our p length. And then we can, this basically means once we are receiving the full information of the package, we can move further on in our process and actually check if we are listening to the package, and then we can execute the code from the assigned package. Therefore, I am hitting a comment because I'm going to say handle data packets, and we are passing in the data, which we are going after we are done with this method. Okay, so within the while loop, but outside the if statement, we are going to say p length equals 0, and then we can say if player buffer dot length is greater or equal to 8, greater or equal to 8, then p length, oops, there you go, then p length equals player buffer dot read long dot false, because we are just peeking. And then we can say if p length is less than 0, then we are going to say player buffer dot clear and return. Then we are done receiving the full package. We are not losing any package, and yeah, that is a great thing. Okay, Now we need to cover up our handle data packets, okay? So that's what we are going to do next. This is pretty simple. As you know, we did read out the package, but we now have another package within the package, and that is what has the packet identifier in it, and that is what we are going to read out. We are checking in our list if we have the package added, and then we are executing the code. So we are going to say private void handle data packets. So we can remove the comment right here. We do need a byte array of data. And yes, we can minimize our handle data and cover up the handle data packets. So we do need a variable of long, which is the packet identifier. And we do need a byte buffer equals new byte buffer, and we do need a packet underscore, which is called packet. Good. Now we are reading out the packet itself, which is then buffer.writeBytes data. And now we only want to read out the packet num, the packet identifier, to make sure that we are actually executing the correct method. So we are saying packet identifier is equal to buffer.readLong. And then we can directly say buffer.dispose. And then we actually try to get a value of our dictionary, which we have added the packet with the correct method. So we can say if packets.tryGetValue, our packet identifier, which is our key, and then we say out our packet. Is that correct? Packet num, comma packet. There you go. And then we can say if the method now checks if we have the packet actually in our list. Then the packet says packet.invoke with our data, and then we are executing the correct method which is assigned to our packet. Great. Now we just need to assign our handle data where we are receiving the packet with our byte array data. And this is basically in our client TCP. Was it in our client TCP? Yeah. Okay, we didn't cover up that yet, so we are going to do that. So basically, as you remember from the first episode, we did a successfully connected to the server. We are going to remove that now. What we are going to do now is basically, we are listening to our stream to receive all the information from the server. So we are going to say, do we have the stream yet? Okay, we need to create a few variables. So first of all, we do need to create a private network stream to actually receive any information from the server. So we say my stream. And we do need nothing else, I guess. We do need a private byte buffer. Do we do that? No, we don't need that. We already have that. Okay, so now we can say else in our connect callback. So if player socket connected false, you are not connected or not allowed to connect to our server. But if we are connected to our server, we are setting up our network between server and client, the personalized network stream. So my stream is equal to player socket.getStream. So we can send data back and forth. Then we can say my stream.begin read. Okay, we are start reading out the stream to receive the data we are sending from the server. And then our byte buffer is our async buffer. The offset is 0. The size is 8192, as you remember. And then we do need an async callback, which will be called on receive, which we are going to create in a second. And our object state remains null. Okay, now we are going to create our async callback. So therefore we are going to create a private void on receive. We do need a parameter of async result, and we call this result. There you go. As you can see, the arrow went away. Okay. This is where the magic happens. Every time you are receiving a package, this method is getting called. Okay. So we are making a try catch block again. Maybe when some error happens that your client won't crash. So try catch. And then we are actually getting the length of the package we are sending. So int byte length, an example, equals mystream.endRead. So we are stop reading because we received the package. And then we say byte array, my bytes equals to new byte with the length of the byte length to fill the byte array with information. And then we can say buffer.blockCopy. So we are copying the array over, which is the async buffer. The offset is 0. The destination is my bytes. And we are going, the offset is 0 again, and the length is the byte length right there. So we are not only copying over everything, we are directly resizing the array. And now we are making a check. So if byte length is equal to 0, then you are not connected anymore to the server, which then we can print out console write line disconnected. Because as I said, once you are connected to the server, you are sending data automatically back and forth to stay connected. And if you are not receiving anything, which is then 0, then you are not connected anymore, which then says you are disconnected, so we can return our on receive. But else, we do need, let's say, well, basically we can, after we receive the package, then we can copy mystream begin read again to receive even more information. So we passed it in right here. But now we need to call our client handle data right there to pass in the byte array, which we are receiving over the network. So to do that, we are going into our general class and we are going to create a public client handle data. We call this handle data equals new handle data. Okay, to initialize the client before we connect to the server, we need to initialize our packets. Okay, so and that is what we are going to do in our general class. So we are going to say handle data dot initialize packets. Boom. Now we actually listen to the packets. We have added everything to the list. And now we can say in our client TCP, we are going to say, as I remember, we are going to say program.general.handledata, and then we are passing in the byte array data, which is my bytes. And now we are actually good to go and we can actually test it right away. Okay, so let's start the server. Start new instance. Server has started. Okay, we are going to start the client, and what should happen now is that the client will receive a message on the on his console, which then says welcome to the server, blah 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 blah. So let's see if that works. And there you go. As you can see, initialize a server connection received on the server side, and now you got your first successful package from the server, which is the welcome message. Awesome, right? This is pretty awesome. But now, actually, what you want to do is you want to send from the client back to the server, right? And that is something we are going to do right now. So close everything. And yeah, so first of all, we are going to create, we can minimize that, So we are going to create a send data like on the server, just on the client, but instead of calling it send data to, we are going to say send data, because we are only sending to the server and not to a single person. So we are going to say private void send data. We need to pass in a byte array of data. And yeah. So what we are going to do right now is basically the same stuff like on the server. We're going to create a new buffer. Equals new byte buffer. We're going to say buffer.writeLong data.get upper bound 0 minus data.get lower bound dimension 0 and everything combined together plus 1, and then we say buffer.writeBytes data, and then we say my stream instead of begin write, we are just writing, because the server always listens to the client. So we can say my stream.write buffer.toArray 0 buffer.toArray.length. And then we can say buffer.dispose to save resources. Okay, as next we can directly create a new network message from the client, a new package. So we are going to say public void send thank you message. And we're passing in a string of message, and we can say byte buffer equals new byte buffer buffer.writeLong. We need a long. Instead of server packets, it is a client packet instead. So client packets.c thank you message. And then we are going to add a string buffer.writeString, our message, and then send data buffer.toArray, and then buffer.dispose. Okay. Good. What we do right now is basically in our client handle data, in our welcome message, what is we are printing out our message, but when we get a message, we automatically want to send back a message to the server. So we are going to say program.general.client.send thank you message with our message. Thank you, I'm glad I have joined the server. Okay, good. The client is done. Now we are going back to the server, which is basically the same on the client, like on the client, but a little bit different. Okay, go to TCP server, right click, add a new class, and we call this class server handle data. Great. Okay. Basically, we can delete everything of that. Okay. Now, if we compare everything, the client handle data and the server handle data, we can actually copy these three variables and pass it in over here on the server. Make it a public class. But now the difference is our delegate needs now a long connection ID. So we actually know which player did send the message, okay? Then we can copy over our initialized packages right there. But instead of listening to our server packets, we are listening to the client packets, which then is the C thank you message. As next, we do have a packet welcome message, which we are going to rename packet thank you message, which we are going to add right now. So we are going to say private void packet underscore thank you message. We do need a long connection ID and a byte array of data. And now we can say, or we copy everything like that. We copy everything from our welcome message into our thank you message, because we are also sending packet identifier and a string. And now we are coming to the handle data. Okay, first of all, we can copy over our handle data, which we are going to do because I'm too lazy to rewrite everything. So copy your whole public void handle data from your client and paste it into your server handle data. But now you see that we run into troubles with the player buffer. Okay. So we are going to fix that. So we don't have a player buffer on our server because we have our specific client. And in our client script, we are going to create a public byte buffer, and we call this player buffer. General, no, wait a second. Program, don't we have a general? It is private, okay. We make it public. And there you go. So we can access it. So program.general.server.client. We do need to pass in our handle data again the connection ID, so long connection ID, so we know which player we are actually receiving data from. So client connection ID dot player buffer. That is a long if statement. Okay, and now we can copy this over and paste it or replace it with every player buffer right there. Boom, boom. Oh, we did a mistake here. Player buffer, player buffer, player buffer, player buffer, player buffer, player buffer. There you go. Player buffer, player buffer. And now we do need to have our handle packets, which we need to pass in our connection ID as well. But then player buffer, there you go. Okay. Now we have set it up on the server, our handle data. Now we are going to create our handle data packets. So we say private void handle data packets. We do need long connection ID and byte array data. Good, and we can actually copy over the same stuff from the client to the server and make a few adjustments. So copy your handle data packets basically over to your server handle data packets. And as you see right now, our invoke will get an error because we need to pass in our connection ID, which we are doing. And now we are good to go. But now we need to add the same way we add our handle data from the client in our stream. We need to do the same with our server stuff. So we are going back to our clients. And then I already did a command right there in our on received data. We can basically say program.general.server. No, that's quite wrong. We go into our general script and we do need to create a public server handle data. We call this handle data as well. Equals new server handle data. In our initialize message, above our server initialize network, we are going to say handle data dot initialize packages. So we can actually assign our packages to. And now back to the clients, we are going to say program.general.handle data handle data, and now we are passing in our connection ID and our new bytes. Perfect. Now we can delete our comment. And now we actually, what should happen now when I start a server is the server should send the information, the welcome message from the server to the client. The client should receive this message, print it out as it did before, but the client then should send a thank you message to the server, which then says, hey, thank you, and the server should print it out as we did set it up right there. I mean, right here. So let's see what happens. Starting the server. Which apparently takes a little bit. Okay, there you go. And now we are going to start the client. Debug start. Awesome. Here's the client. As you can see, welcome to my game server. You are connected to World 1, says the server. And the server got the message, thank you, I'm glad I have joined the server. And that's how you basically send data between the client and the server. I hope you guys did enjoy this tutorial, and I would love to see you in my next project here. And yeah, if you still have questions about the networking, you can write me a private message. I will be there for you. You can write me on my Facebook page, on my Discord channel. Check out my profile. There should be all information you will need. But yeah, thank you guys for tuning in, and take care of yourself, take care of your project. Keep coding, never give up, and see you guys in my next project. Thank you for watching, and bye.